Warning, this video assumes you understand pH, molarity, and basic algebra. If you do not, you may feel lost. We'll start with a quick review of pH. pH measures acidity. You calculate it by taking the negative log of the concentration of hydrogen ions. Strong acids, when dissolved in water, dissociate completely into hydrogen ions and the conjugate base of the acid. So the concentration of hydrogen ions equals the concentration of the acid with strong acids. To calculate the pH of a strong acid, simply take the negative log of the concentration of the acid. For example, the pH of a 0.1 molar hydrochloric acid solution is the negative log of 0.1, in this case 1. If the concentration is 0.01 molar, the pH is 2. 0.001 molar hydrochloric acid has a pH of 3, and so on. You get the idea. So what happens if the acid is very dilute, say 10 to the negative 8 molar? The negative log of the concentration gives us a pH of 8. The problem with this is any pH greater than 7 is basic. So how can an acid be basic? The answer? It's not. If the concentration of the strong acid is less than 10 to the negative 6 molar, we have to account for the dissociation of water. In water, the concentration of hydrogen multiplied by the concentration of hydroxide is 10 to the negative 14 at room temperature. So how do we actually calculate pH of a 10 to the negative 8 molar hydrochloric acid solution? We have to do some algebra. Say that the concentration of hydroxide is X. For every hydroxide produced by the water, a hydrogen also has to be produced, so the hydrogen concentration from the water is also X. However, water is not the only source of hydrogen here. We also have to add the hydrogen from hydrochloric acid. So the concentration of hydrogen becomes X plus 10 to the negative 8. Reminder that the concentration of hydrogen multiplied by the concentration of hydroxide equals 10 to the negative 14. So you get the equation X times the quantity X plus 10 to the negative 8 equals 10 to the negative 14. Do some rearranging of the equation and you get x squared plus 10 to the negative 8x minus 10 to the negative 14 equals 0. Pull out the quadratic formula from algebra and you get x equals a negative 1.05 times 10 to the negative 7 or 9.51 times 10 to the negative 8. We can't have any negative concentrations, so X, the concentration of hydroxide, equals 9.51 times 10 to the negative 8 molar. We determined earlier that the concentration of hydrogen is X plus 10 to the negative 8. Plugging in our value for X, we get 1.051 times 10 to the negative 7 for our concentration of hydrogen. Taking the negative log of this, we get a pH of 6.98. Very slightly acidic, which makes sense because the acid is very dilute. For concentrations less than 10 to the negative 8 molar, you can assume for most practical purposes that the pH will be neutral because the hydrogen concentration from the acid is very small compared to the hydrogen concentration from water.